Every day we make hundreds of decisions. Should I invest? Is this person actually talented, or was that just luck? Most of us believe we're making those decisions logically. But here's the strange part. Even intelligent people, mathematicians or professional investors, regularly make predictable mistakes. Not because they aren't smart, but because our brains weren't designed to think naturally about probability. Today, I want to show you 7 ways our intuition quietly tricks us, and how understanding them completely changes the way you look at the world. Let's start with the biggest misconception of all. Most people think risk means danger, but it doesn't. Risk is uncertainty. Driving to work carries risk. Crossing the road, investing, all of these things carry risk. Even staying exactly where you are carries a risk. Once you realize that, you stop asking, is this actually dangerous? And start asking, what are the chances? What happens if I'm wrong? What are my alternatives? That one shift changes almost every decision you'll ever make. But even if we understand risk, our brains still make another mistake. We love small samples of things. Imagine meeting someone once. Would you know exactly what they're like? Probably not. Yet, we do this constantly. We go to a restaurant once, or we make one particular investment, or we watch one football match and suddenly we're hooked. One interview might go very well or very badly, and that instantly impacts the rest of them in our life. Suddenly, we're convinced. Small samples of things alter our perspective of what they actually are. And this is because of a concept about randomness. In small samples, randomness dominates. The fewer times you do something, the more chance a random event can actually occur. Let's take flipping a coin, for example. If you flip a normal coin that has a chance of heads or tails, you've got a 50% chance for either one of them. If you flip a coin 5 times, there's a chance that you have 5 heads come up from that result. This in itself is quite unlikely as a probability, but because we have only flipped the coin 5 times, probability itself can't even out. We actually need more coin flips to understand that the 50% chance is actually real. And the problem gets worse, because once we think we've found a pattern, our brain refuses to let go. So let's consider this example. I flip a coin and I get heads 5 times in a row. Now, if you ask someone what comes next, many people instinctively say, well, tails should come next because it's due to come up. But not because they know that it's tails, it's because it feels right. It feels like it needs to balance itself out, because at the moment the coin flips have been random, because there's still a 50% chance that either will come up. But each of those coin flips are independent events. Each one has a completely unique event based on what has previously happened. The next time I flip a coin, I still have a 50% chance for heads and a 50% chance for tails. This, however, is only really seen when we look at larger numbers. And this is a topic known as the law of large numbers. The fact that in a small sample, a coin flip won't balance itself out. There may be more heads or more tails in a small sample, whereas if we did this over 1,000 coin flips, you would have fairly close to 500 being heads and 500 being tails. And our brains just really hate randomness. So we frequently invent patterns to account for things. But even when we understand the randomness, we still judge decisions very badly. So let's imagine a game, okay, where you can bet on two separate things. Bet A, we have a 90% chance of winning, and we would win £10, but only a small chance of losing £1. Okay, so that's 90% chance that we win £10, but if we lose £1. Or bet B, we have a 10% chance, if we bet on bet B, a 10% chance of winning £100, but if that loses, we lose £50. So which is better? Well, from a statistical point of view, bet A is better because you have a higher chance of winning the money, even though it's a small amount of money. Whereas bet B, you have a smaller chance of winning a larger amount of money, but you still would then potentially lose a larger amount. But even though this is true, it still doesn't explain precisely which we should choose. There is still a chance, even if we make a good decision and choose bet A, that we lose money. And even if we make a bad decision and choose bet B, there's a chance we win the money. So sometimes we have to actually judge the process of what's going on and whether or not it is sensible to take that at all. And this leads to perhaps the biggest mistake of all, which is only looking at the winners. This is known as survivorship bias. Now, during World War II, there was a Hungarian statistician who was looking at the way planes came back from the war with bullet holes. Now, these planes had bullet holes in specific areas, and the common thought was, great, we need to protect those areas more. We need to put more armour on them because they've got loads of bullet holes in. But what this man did was actually realise the planes that had come back were absolutely fine. It was the ones that hadn't come back from the war that needed protection in different places. The data and the information that was required to make improvements were on the planes that were missing. And that was where he decided that they needed to improve the armour on the planes to survive. Just because we have the information doesn't necessarily mean it's the correct information. Now, we see this in many situations. YouTubers, for example, who are at the top of their game, businesses and investors. We normally only study those who are at the top, but we don't consider studying those who have made the mistakes beforehand. Because why would you copy someone who's made a mistake? But that's not necessarily the point of the survivorship bias. The point is you learn from the mistakes and potentially still copy the winners, but making sure that you're understanding why that makes them a winner. What's the differentiating factor that actually puts them ahead of the people who didn't succeed? Finding the missing evidence is often the most important bit of evidence. Now, one final idea that's going to tie all of this together, and that is known as the regression to the mean. If you have a student, say for example, who takes 10 exams and scores 100% in all of them, and then on their 11th exam they only score 80%, would you now judge that student based on that 180% and say that they have regressed in their learning? Or take football, for example. If a goal scorer has scored in every single match and then has 2 games where they don't score, do we now say that they're out of form or not a good player anymore? Personally, I would find that a little bit unfair because according to what we refer to as the mean, the average of all of those games, the player has still scored almost 1 goal per game. But just a few games makes the perception of what people think completely alter. This is the same in, say, for example, financial markets, where a market may have grown 20% over the course of a year, and then the following year only grows 5%, or even worse, declines 10%. This doesn't necessarily mean the market or the stock of a company is now worth less. It would actually just mean, well, maybe the period of time that we're looking at isn't long enough to understand the growth, because over, say, 10 years, the company or the market might have grown on average 10% per year. And last year, where it grew 20%, was an abnormal year, and this year where it's declined might have been due to other circumstances. So what's the actual lesson behind all of this? Well, instead of asking what's happened within a situation, we need to start thinking about why it's happened, how likely something was to happen, how much evidence do we have as to why this is, or could this simply be due to randomness? Now, these weren't 7 different lessons. They were 7 different ways of describing the same problem. Our intuition is incredible. It helps us recognize faces, learn languages, or even navigate the world. But when uncertainty appears, it begins making shortcuts. And sometimes those shortcuts help us. Sometimes they quietly mislead us. The goal isn't to stop trusting your intuition. It's to know when to pause it and think one step further. Because the best decisions aren't made by people who can predict the future. They're made by people who understand uncertainty. If you've enjoyed this video, every one of these ideas has its own full explanation on the channel. Over the next series, we're going to be applying these ideas to investing, sport, psychology, and everyday life. I'll see you there.